Good afternoon, everyone. Welcome to GIS Day celebrations at ENVIS Center, Indian Institute of Science. So today we are celebrating GIS Day, which provides an international forum for users of geographic information system and technology to demonstrate the real world, what are the applications available, and make the difference by using these technologies for the societal development. So GIS Day is a fun day activities which showcase how GIS can be effectively used and discover the various options and benefits available through GIS and inspire the community across the global. And this in this regard, we are celebrating GIS Day at Indian Institute of Science to motivate the students and also make sure that students take part and learn the GIS and use the GIS effectively for their daily applications. So when you consider the GIS Day, it has formally started in the year 1999, and ESRI has partnered it, and they have taken up further levels, and they are trying to inspire the community across the globe. So now GIS Day is happening because of the passion for geospatial learning across the globe, and also the this event mainly helping to understand the GIS and power of GIS and make the community use the GIS for their application for their needs. So now I request every one of you use the GIS and understand the power of GIS and inspire with your application and change the world through the GIS. So I request everyone to take part in learning GIS and also make use of GIS. In this regard, our center at Indian Institute of Science, we are conducting two important and thought-provoking talks on land use analysis using big spatial data and GIS by Tulika, and another important talk on machine learning techniques in understanding land use dynamics. So I welcome Tulika and Paras for this session. So I hope the students will benefit by this interactive session. And if you have any queries, please post in the comment box and subscribe to the channel for more innovative and also informative sessions. Thank you, one and all. I request Tulika to take over.
Good afternoon, everyone. Today we'll discuss about land use analysis using big spatial data and GIS, as this is the celebration of GIS Day. To begin with that, we'll see what is GIS. So GIS is a mainly framework for gathering, managing and analyzing the data, which integrates many types of data, which we can also call as a big data, and it analyzes it in a spatial location and the information, and further it visualizes the maps into 2D or 3D scenes. And we can use remote sensing and GIS for spatial data analysis, which for example we can see that we can analyze the forest fires, or we can track the growth of a city, of any land cover or land use. Then we can understand what is the change dynamics. So, what is the use of big data in GIS? In GIS, we use the big data to identify problems, and that can be helpful to manage and respond to different kinds of events. Also, we can monitor the change and perform forecasting or modeling for future analysis and understand the trend. Using GIS, we can create maps by using the data, and using different GIS applications, different kinds of GIS analysis can be done. So, what is big data or remote sensing data? Big data or remote sensing data is mainly acquired by different spaceborne and airborne sensors, which have many different characteristics. Among them, main characteristics is shows spatial resolution, which gives the idea of how much area is covered by the sensor image. We can see there are multiple types of multiple types of big data available with different spatial resolution. We can see that Landsat spatial resolution ranges from 60 meter to 30 meter, whereas list for data has a 5.8 meter spatial resolution. Sentinel data gives us 10 meter resolution till 60 meter resolution, and for a larger area we can use MODIS, which gives us up to 1 kilometer of spatial resolution. And there are different categories of big data according to the spatial resolution, on the basis of sensor, and also the area of application, and also the temporal resolution of the data. So, what are the applications of big data in GIS? Using big data and implementing the geographical information system, we can map the vegetation. We can also map the land cover. We can understand the agricultural practices in the region. Also, cropland mapping can be done. Ecosystem assessment and vulnerability of biodiversity can be assessed to GIS. Disaster, it helps in disaster management, also in urban monitoring. GIS also helps in hydrological analysis and climate and atmospheric monitoring, and there are many other applications of GIS. And implementing GIS and artificial intelligence, there are mainly two sections of artificial intelligence which GIS incorporates. One is geospatial machine learning operators, which consists of clustering, classification, and regression, and other one is geospatial deep learning operators, which analyzes the 3D data and the satellite images for land use classification. And machine learning is a subset of artificial intelligence, which analyzes the data, analyzes the data on the basis of the input and gives us the output uh, uh, according to the model. So, application of artificial intelligence and machine learning can be of various kinds in GIS, which includes the land surface monitoring, which also can analyze the impervious surface and detect the change. Also, agricultural activities can be analyzed, and road network analysis and object identification can also be done with artificial intelligence and machine learning. And for land use analysis, there are few steps to acquire the particular analysis of a land use. First, we generate a first color composite from the satellite image. Then, we by creating training polygons and the bands from the satellite image, we use the particular classifier for the classification. And to validate our result, we do the accuracy assessment. And when our result is 80 more than 85% accurate, we do the area calculation to finalize what is the to quantify the land use of that area. Here I have shown the case study of Hassan district, and how machine learning based mapping and prediction has been done in that study area. Now, Hassan district is in southern district of Karnataka, which is has a hilly zone in the western section and the southern dry zone in the eastern section. And the district is mainly the district has mainly agricultural based activities in the eastern plain section, whereas horticultural activities can be seen in the western higher hilly region. Also, the region has a good amount of evergreen forest in the western Ghat part, which is in the western portion of the district. And the data we used for the analysis of this district are Landsat data from 1973 to 2022. And for Landsat data, we have used Landsat 1 for Landsat MSS, Landsat Thematic Mapper, and Landsat OLI. And also, we have used the SRTM DEM for hydrological analysis. So, for our land use analysis, first we have collected the field data and different data from different big data sources, and then we have generated the false color composite, and by training collection of the training data and implementing the random forest classifier, we have classified the land use of that area. And by using cellular automata Markov model, we have simulated what will be the future land use of that area in 2030 and 2038. Random We have used random forest classification for our area, because random forest uses a number of decision trees to give the accurate result for the classification. And it is based on the majority votes of the prediction, and from this the from this ensemble method, we can acquire a better classified result than other classifiers. And by implementing random forest classifier, we have analyzed the land use characteristics of Hassan district from 1973 to 2021, which where we can see that the evergreen forest has decreased from 10% to 2%, and the agricultural and horticultural activities has been in together has been increased from 1973 to 2021. Also, the built up area has increased from 0.5% to 3.63% in 2021. And we have done also the future modeling of the area, which helps us to monitor the various conditions of the sustainable development, and also helps us to account for appropriate spatial patterns of future land use pattern. And it helps in interpreting the spatial changes and the landscape conservation through ecosystem protection. And the CA model which we used the 5 into 5 filter for the analysis. And a CA model basically is based on the physical environment and the neighborhood. So using this model, we have predicted the and land use of 2030 and 2038, which shows that the evergreen forest will be further degraded up to 2.18% in 2038. And the also we can see the deciduous and scrub forest will also increase it to 0.85% and 0.74%, whereas horticulture in the area will increase, and the built up will increase up to 5.49%. And in the conclusion, we can say that the rapid changes in land use can in the district can have environmental impact. And the analysis of the land use change shows that the forest cover has been decreased by 8%, and where the whereas the urban area has increased by 3.1% in last 5 decades. And horticultural land has been replacing the forest evergreen forest cover in this region. Also, in the hilly region, the some of the forested areas has been converted into agricultural lands. So modeling and geovisualizing visualization of the area using GIS assists us in identifying the problematic changes and their effect on environment, and it can be used to delineate the ecological sensitive zones. So it is suitable, and so it is uh, so the timely management measures should be taken on the basis of the analysis for sustainable development and to protect the biodiversity, to reduce the severity of the changes in this region. Thank you. So, should I announce the later? And after thank you for listening to my talk. And I will like to request Paras for his next presentation on machine learning techniques in understanding land use dynamics. Thank you. I will request Paras to take over.
Good evening to all. And as we are celebrating the GIS Day, uh, on that occasion, I am trying to give some knowledge about the machine learning techniques to understand the land use dynamics of landscape. And as machine learning is an application of artificial intelligence that analyzes the to analyze and make decision by itself without any human intervention. And machine learning provides system the ability to automatically learn and improve from the experience without explicitly coding. And machine learning usually starts with some knowledge and corresponding knowledge organization so that it can interpret, analyze, and test the knowledge acquired. And as we know that machine learning algorithm, it is divided into mainly in four on based on their training type. One is first is supervised, second is unsupervised, third is semi supervised, and fourth one is reinforcement learning. And by their by their learning style, they are classified into four type that algorithm can be supervised, in which the training data is the labeled data. And it basically learn the pattern or of the training data, and then it predict the results. And some of the example of supervised learning techniques are k nearest neighbor, linear regression, support vector machine, decision tree, and random forest, and also neural networks. And the unsupervised learning techniques, they just train on the non-level data, and they doesn't know the results, or they only just create the clusters based on the patterns and the similarity of the data. They just create clusters, and they then deduce the structure from the input data. And some of the examples are k-mean clustering, PCA for dimensional reduction of the dimensionality, and association rule learning. And coming to the semi supervised learning, it works the input for the semi supervised learning is mixed type, labeled or unlabeled. Both it take both the input. And model learns the structure to organize as well as predict the results. And the both we can do classification and regression, both operations. And algorithm are extensions to other flexible method that make assumption about how to model the unlabeled data. Labeled data can be easily predicted, or but there is an difficulty in predicting the unlabeled data and to train it. And some of the example are like photo hosting services like Google Photos, which based on the semi supervised learning technique, they give the results. And reinforcement learning, action is taken by observing the environment similarity or the human learning behavior. And it learns upon the machine learns on the behavioral pattern or behavior of the data. And it is driven from the earlier experience driven learning. And some of the examples are autonomous car behavior and autonomous drones. And the building block for the machine learning, to train the machine learning, is the training and the testing. And it is important to take significant training data for the classification or for better results, or with for the accuracy. So it is important to first analyze the area or the data, and then choose the appropriate technique for the for classification or regression operations. And training data is responsible for the classification or regression for the final results, and the testing data is for the just checking or the cross checking the accuracy of the trained data or the trained results. And based on the testing, we can predict also for the likely changes. And as land use and land cover is just a physical cover over the earth surface, which contains vegetation, water, soil, and physical cover elements. And land use is that we can refer that land use is how the land is used by the human for its own purpose. Is the We call it as land use. And land use land cover changes is a widespread and accelerating process due to anthropogenic activities as well as the natural phenomena, and which affects the natural ecosystem. And remote sensing data along with integrated with GIS provides a suitable platform for data analysis, updates, and retrieval, and the analysis and monitoring of a particular uh, phenomena. And now high resolution satellite data and more advanced image processing technique has now emerged. And so GIS technology has also emerged with the for the land use and land cover change mapping. And the basic for land use classification, basically four type of classification, or we can choose approaches for classification are unsupervised, supervised, hybrid, and fuzzy classification. The I have one case study here, which is of Raichur district of Karnataka. It is also known as the cotton bowl of Karnataka, and it has a geographical extent from 15 degree to 16 degree latitude and 76 degree to 77 degree longitude, and it has a geographical area of 8,442 square kilometer, and has a population of about 2.3 million. And it has a dry climate for the major part of the year in the major geographical extent of the district. And it receives about 71% of annual rainfall in the during the southwest monsoon. And the data what we have used for the our analysis is the Landsat series data from 1973 to recent 2022. And for that, for earlier images we have used MSS thematic mapper and enhanced thematic mapper, and now the latest operational land imager for our recent study. And also for the 30-meter resolution SRT dam from and this data we had collected from the USGS USGS survey, geological survey archive. And the method what we have used is we have the primary data is the satellite data, and secondary data as the land use or the uh, ground data. And based on that, we divided 74% 70 in a 70/30 ratio, 70 for training data training and 30 for testing. And uh, we use random forest classifier machine learning, which is a machine learning technique. And based on that we have analyzes our land use, and land cover analysis has also done. And based cellular for the prediction, cellular automata is used for the simulation or prediction of the likely land use changes. And coming to the algorithm, what we have used in the land use classification is random forest. It is an ensemble classification method. It is an ensemble of decision trees or cart we can say that uh, it is random forest search only. It search the random subset of variables for a split and is not to minimize the it minimizes the correlation between the decision trees, because it is a ensemble of many decision trees. So it is important to reduce the correlation between the between different decision trees. And it maintains the multivariance between the decision tree or the uh, training samples, and it is less sensitive to noise or overtraining, as resampling is resampling of weight is based on the random sampling. This is a land cover analysis, which shows that the vegetation has increased from 38.24% to 55.83% because of the availability of the water in the district, and the proper irrigation system. The vegetation cover has increased. And now land use analysis, we have done the land use analysis for we have classified it in 7 classes. And we can see that in the Raichur district, uh, it has emerged at a and the buildup has increased uh, rapidly in the Raichur district. Buildup has increased from 0.23% to 1.04% from 1973 to 2022. And the paddy rice, it is a basically a agrarian district in which paddy rice is grown in a huge amount. And we can see from the light green color, this denotes the paddy in the paddy yield in the Raichur district. And it has gone up from 0.7% in 1973 to 18% in 2022. And as a result of urbanization, scrubland and open land has decreased sharply. This is the analysis of likely changes in land use of Raichur district from 1973 to 2022. We can see that water has increased from 0.38% to 0.92%. And the forest has come down from dry deciduous forest 2.14% to 2.02%. And the scrubland and open land has decreased sharply. Scrubland has decreased by from 5.8% to 2.08%, and open land from about 7% to less than 1%. And the paddy rice has increased from 0.74% to about above more than 18%. And for the modeling, why we need modeling for the we need modeling for the to simulate the likely changes uh, in the near future. uh, Considering the current rate, we predict the uh, uh, results for the for the in the near future. And for that we have used the CA Markov automata, uh, in which Markovian process, it is a random process which defines the suitability of state as a linear weighted sum of the affecting factors. And the effect of neighborhood influence is determined by the filters. And in our study we have used the 5 by 5 diamond filter, which is also known as Won's Newman filter. And based on the transition probability of two time stamp land use maps, we have simulated the likely changes in the near future. and this is the simulated. The validation, we simulated for the recent time. What is the difference, or what is the agreement between the actual and the simulated maps, and we got a good agreement for actual and simulated map with greater than 0.95 kappa standard. So we further simulated for the year 2030 and 2038, and we can see that it is predicted that the build-up area with this change rate will be reach to 7.28% in 2030, and about 9% in 2038 with the current rate, because of in the expansion of road networks and the increasing industrial involvement, and the city is also, no, the district is also expanding, and many cement factories has come up in the vicinity of that main cities in near around Raichur city. Mainly it is expanding, and finally on comes on the conclusion. We have analyze the land use dynamics of Raichur districts, which show using machine learning technique, which shows that the buildup has increased from 0.23% to 1.04% from 1973 to 2022, and we observed that random forest is the best machine learning classification for technique for land use uh, to for the highly agrarian landscape, and cellular automata Markov model have the ability to represent the nonlinearity and complex spatial distribution of land use. And you all are invited in the lake symposium, which is from 28th to 20th to 30th December in 2022 in IISC Bangalore. Thank you.
Thank you, Paras and Tulika, for sharing your work, and it might help many researchers and students to understand how geospatial technologies can be effectively used for understanding the land use, land cover changes. At the same time, how we can use GIS to quantify the changes effectively through various and also predict what could be the probable or likely land use changes in the region. So one has covered on the forest dynamics, other person has covered on agriculture applications, how GIS can be effectively used, and you can derive conclusion from the geospatial data. So there are two questions for Paras. So there is a question on how agriculture land is decreasing and paddy rice is increasing. What did you include in agriculture? So can Paras share the details?
We have segregated the paddy rice from the because the district comprises the mainly paddy rice. So we have segregated the paddy and other agriculture as like cereals and pulses. They comes under the agriculture, and the only paddy we have segregated it, in a separate. So to see the change in the uh, paddy field or the paddy yield due to the availability of water in the district.
Okay, thank you. So hope Rajesh you got answer, and Sumit also asked on the similar lines. So Rajesh and Sumit, I think Paras has made it clear. So he wanted to understand how the increase in paddy taken place because of the water availability through the construction of the reservoir as well as the upgrading the existing stream network. So hope it has helped you people. So there, if you have any questions, please post in the comment box so that we will try to get it clarified. So there are appreciations for Tulika, madam. It's a great work. Thank you for spreading your knowledge. So Pooja and Mohit, thank you for the appreciation, and we look forward for your active interaction in our coming sessions also. So if there are no more questions, and I thank Tulika and Paras for sharing their research on land use dynamics through GIS and remote sensing, especially geospatial technologies. So with this, we are ending this session, and I request everyone to subscribe the channel so that you will come to know uh, whatever the presentations we schedule for the near future. So hope this talk has useful for you people. So I am ending here. Thank you one and all for active participation.